Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium, and in this session we are going to learn about ionic product of water. Ionic product of what? Water. Let's start the session. Okay. See here ionic product of water. Ionic product of water. So first thing is water is weak electrolyte. First thing is pure water is very weak electrolyte. Very weak electrolyte. What is the meaning of very weak electrolyte? Why it is very weak electrolyte? Because its dissociation is very much less. Its dissociation is very much less. If it gets dissociated, let us say water, if it gets dissociated, it dissociates into H plus and OH minus. So here water dissociation is very much less. That means out of huge amount of water, very less amount of water dissociates into H plus and OH minus. So it is weak electrolyte because its dissociation of water is very much less. Very much less. So dissociation is very much less is represented in the terms of degree of dissociation. If its degree of dissociation is very much less, then its dissociation will be very much less. So we can say that degree of dissociation, how do we represent degree of dissociation? We have studied in chemical equilibrium. It is represented as alpha. Its degree of dissociation is very much less, or very less. Okay. So what is degree of dissociation? Already we have studied. What is degree of dissociation? Alpha is equal to number of moles dissociated, number of moles of a substance dissociated by total number of moles taken initially. So if you are taking water, for example, if you take 100 moles, very less number, 0.1 moles are dissociating. In that way, simply speaking, its degree, it dissociates very much less. As water dissociates very much less, we say that pure water means it does not contain any other salts, minerals, whatever it is, only water is present, and that's called as water, pure water. Okay, so pure water is weak electrolyte because its degree of dissociation is very much less. We can also say that its dissociation, it dissociates to very much less extent. That's the reason why it is a very weak electrolyte. What is that? Pure water. So we are speaking about ionic product. So it dissociates into two ions. It dissociates into two ions. What are those two ions? One is H plus, another is OH minus. Actually, when it dissociates in water, H plus is unstable. What we say, H plus here is also called as what? A proton. H plus is also called as a proton. Proton is highly unstable. So here what is there? Here water is there. So one molecule, what is happening? One molecule of water dissociates into H plus and OH minus. Around this H plus, what is there? Again water is also there now. So this H plus readily combines with the water molecule to form H3O plus. H3O plus. So what is this H3O plus called as? Hydronium ion. What is that called as? A hydronium ion. What is this H plus called as? H plus is called as hydrogen ion. So in water, H plus is released. This H plus, as it is unstable, it readily combines with the H2O water near it and forms hydronium ion, H3O plus. H3O plus. So dissociation of water can also be written in this way. H2O plus H2O gives rise to H3O plus plus OH minus. Because one water molecule dissociates into OH minus and H plus. This water molecule combines with H plus and forms H3O plus. So dissociation of water can be also represented in this way. H2O plus H2O gives H3O plus plus OH minus, or simply representing dissociation of water can also be represented in this way. What is that? H plus and OH minus. H2O gives rise to H plus and OH minus. Then why did we write this forward arrow and backward arrow? Because when it is a weak electrolyte, there will be an equilibrium existing between dissociated ions and non-dissociated molecule. Are you getting this? What is this? When it is a weak electrolyte, whenever the electrolyte is weak, there will be an equilibrium existing between dissociated ions and undissociated substance or undissociated electrolyte. That is the reason why we have written both forward and backward. That means both forward reaction and backward reaction occurs. So whenever we find that it is weak electrolyte, compulsorily we have to mention this forward arrow and backward arrow, so that we will come to know that this is weak electrolyte. Are you getting this? Okay. So it is dissociating into ions. It is dissociating into ions. What ions it is dissociating into? It is dissociating into H plus ion and OH minus ions. So this product of these ions produced from water is called as ionic product. In detail, if you speak about the product of concentration of hydrogen ion and hydroxide ion. Hydroxide is what? OH minus. So OH minus is called as what? Hydroxide ion, right? Hydroxide ion. So now you can see, at any temperature in pure water, in any aqueous solution, in pure water or in any aqueous solution. Aqueous solution means some other substance is dissolved in water, is known as ionic product of water. So ionic product of water is represented by what? Kw. Is represented by Kw. So Kw is equal to, what is that? A product of, see, H plus ion concentration into OH minus ion concentration. H plus ion concentration into OH minus ion concentration. And this is called as ionic product of water. Or it can also be represented as H plus is unstable, it combines readily with water to form H3O plus. It can also be represented as H3O plus ion into OH minus ion. Either the way you can represent. Okay. Now let us see here. We are seeing that pure water. So what is that? Pure water. So pure water dissociates into H2O, dissociates into what? H plus ion concentration, H plus ion and OH minus ion. Right? Now let us write equilibrium constant for this. If I write equilibrium constant, we know how to write equilibrium constant. So K equilibrium is equal to H plus ion concentration into OH minus ion concentration, right? By H2O concentration. So H2O is what a liquid. H plus is it is released, it is present in water, so we can take aqueous. Right? Now let us see what is the concentration of water. How to calculate concentration of water? Let us see. Concentration of water. So concentration of water is represented in the terms of molarity, number of moles by volume expressed in liters. So 1 liter water, we know that density of water is equal to 1 gram per 1 ml. If you are taking how much volume water? 1000 ml. So 1000 ml will be equal to 1000 grams. Are you getting this? You are calculating what is the concentration of water. What is the concentration of water? Because we got it, concentration of water here. Are we getting concentration of water here? Yes. So we need to calculate what is concentration of water. Concentration of water is equal to molarity. We are expressing it in molarity. Molarity is equal to number of moles by volume in liters. We are taking 1 liter water. 1 liter water is equal to 1000 grams. So let us calculate molarity. Molarity is equal to number of moles by weight by molecular weight by volume. Volume is how much? Volume in liters. So weight how much? 1000 grams by what is the molecular weight of water? 18 by gram molecular weight. Volume in liters is 1 liter we have taken. That is equal to 55.555 molar. 555 means totally 55.56. Approximately we get a 55.56 molar. This is the concentration of water. What is that? Concentration of water. So this concentration of water, as we know that the degree of dissociation of water is very much less, or dissociation of water is very much less, its concentration remains same. Its concentration remains same. It does not change. Now rewrite this formula. I can write it as, how can I write? K equilibrium into concentration of water is equal to H plus ion concentration into OH minus ion concentration. So this equilibrium constant into concentration of water is called as Kw, is H plus ion concentration into OH minus ion concentration. What is this Kw called as? Kw is called as ionic product of water. What is that? Ionic product of water. This ionic product of water is dependent only on temperature. Dependent. It depends only on temperature. Only on temperature. It is temperature dependent. It does not depend on any other factor. It depends upon only temperature. Right? So as it is depending upon temperature, we need to mention the temperature at 25 degrees centigrade, that is equal to 298 Kelvin. 25 degrees centigrade is equal to 298 Kelvin. At 25 degrees centigrade, Kw is found to be 1 into 10 power minus 14 mole square per liter square. How much? Kw is found to be how much? 1 into 10 power minus 14 meter square per mole square per liter square. This is ionic product of water. It is practically calculated. It is an experimental value. Compulsorily, when you are mentioning Kw, you need to mention at what temperature the Kw is, because Kw depends upon only temperature. It does not depend on any other factor. Okay, and we know that Kw is equal to H plus ion concentration into OH minus ion concentration. So one water molecule produces one H plus and one OH minus. So from this I can write H plus ion concentration is equal to 10 power minus 7 mole per liter, and OH minus ion concentration is equal to 10 power minus 7 mole per liter. Okay. H plus ion concentration and OH minus concentration are same, because one water molecule produces one H plus and one OH minus. So now I can write Kw is equal to H plus ion concentration is 10 power minus 7 moles per liter into OH minus ion concentration is 10 power minus 7 moles per liter, which is equal to 10 power minus 14 mole square per liter square. Okay. 10 power minus 14 mole square per liter square. So this can also be represented as capital M square. M is molarity. Molarity is mole square per liter square. Okay. So this can also be written as M square, capital M square. Capital M means mole per liter. Understood? Okay. So at 25 degrees centigrade, this is what? Now you will be asked on increasing temperature, what happens? On increasing temperature. On increasing temperature, what happens? When you increase temperature, the bond between H plus and OH minus, that means more number of water molecules dissociate. Its dissociation increases. What happens? It's dissociation. Whose dissociation? Dissociation of water. Its dissociation increases. What is that? Its dissociation increases. Its ionization. Water ionization increases. So water ionization increasing means we can see degree of dissociation increases. That means alpha increases. Now only we have spoken what is meant by degree of dissociation. Degree of dissociation means alpha. So when you increase temperature, more number of water molecules dissociate into H plus and OH minus. More number of water molecules convert into H plus and OH minus. So more number of water molecules converting into H plus and OH minus means that its dissociation is increasing. Dissociation is increasing means alpha is increasing. Okay. For example, on increasing temperature. For example, if I take an increasing temperature, on increase in temperature up to 50 degrees centigrade, let me take. Its H plus ion concentration is 10 power minus 6 moles per liter. For example, we are taking. It's not exact value. For example, we are taking. Is 10 power 6 greater than 10 power, is 10 power minus 6 greater than 10 power minus 7 or lesser than 10 power minus 7? No doubt about it. 10 power minus 6 is greater than 10 power minus 7. That means it is increased. If H plus is 10 power minus 6, then what will be OH minus? OH minus ion concentration also will be 10 power minus 6 moles per liter. Why? Because when one water molecule dissociates, one H plus and one OH minus are produced. Okay, now what will be Kw? Kw at 50 degrees centigrade. We are mentioning clearly, we are mentioning temperature. At what temperature? Kw is equal to H plus ion concentration into OH minus ion concentration, which is equal to 10 power minus 6 moles per liter into 10 power minus 6 mole per liter, which is equal to 10 power minus 7, 10 power minus 12 mole square per liter square. Capital M square. Capital M square. So what does this represent? On increasing temperature, Kw is increasing. On increasing temperature, Kw is increased. On increase in temperature, Kw increases. On decreasing temperature, Kw automatically decreases. So Kw is depending upon only temperature. Okay. Kw is depending upon only temperature. Next, let us see. Now only we have seen that, what did we discuss? We have discussed that Kw is equal to K equilibrium into concentration of water. Kw is equal to K equilibrium into concentration of water. Now I want equilibrium constant of water. What will be equilibrium constant of water? Kw by concentration of water. Before have we discussed this? Yes, see here. Kw is equal to, see, Kw is equal to K equilibrium into concentration of water. Are you finding this? Okay. Kw is equal to K equilibrium into concentration of water. That is what we are speaking about. About that we are speaking here. Okay. Now, if I ask you K equilibrium constant of water, what is equilibrium constant of water? If you are not mentioning, if temperature is not mentioned, compulsorily we have to take at 25 degrees centigrade. So I can take it as at 25 degrees centigrade. I can write it as equilibrium constant is equal to Kw. We know that 10 power minus 14 mole square per liter square. And concentration of water we have discussed before. How much? What is the concentration of water? Have we discussed this? What is this? 55.56 or 55.5555? So let me take it as approximately what? 55.56 molar. Then what is the equilibrium constant of water? Equilibrium constant of water will be equal to how much? I can write it as 100 into 10 power minus 16 molar cancel by, if I take what is that, 55.56, then I get approximately 1.8 into 10 power minus 16 molar. So this is equilibrium constant of water. What is that? Equilibrium constant of water. What is equilibrium constant of water? What is its value? You see, what is its value? Its value is 1.8 into 10 power minus 16. 1.8 into 10 power minus 16. So this one is competitive examination question. We need to remember that. Okay. Next, coming to here, what is the degree of dissociation for pure water? They will ask. What is the degree of dissociation for pure water? So we know that, let us take H2O here. What is that? H2O dissociates into H plus and OH minus. Okay. H2O dissociates into H plus and OH minus. At time T is equal to 0, reaction has not started. So we have C concentration. The concentration of water is already, we have studied that it is 55.56 molar. It is equal to 55.56 molar. So let alpha be the degree of dissociation. So at the time T is equal to equilibrium. Okay. So what we are taking here, let alpha be degree of dissociation. Degree of dissociation of water. So how much is dissociated? C alpha is dissociated. Then how much H plus is formed? C alpha is formed. C alpha. This we have studied in chemical equilibrium detailing, how to write this C alpha, alpha. If you are having any doubt here, please go through the videos of chemical equilibrium, then you will be able to know. Originally, how much water is present? C concentration. How much is dissociated? C alpha. How much will be remained at equilibrium? C minus C alpha. C minus C alpha. So initially at time t is equal to 0, that is reaction has not started. The concentration of water is C. No doubt, as it is weak electrolyte, it will be reversible, and at a certain time you will find this reaction is in equilibrium. At equilibrium, some of the water is converted into H plus and OH minus. How much water is converted into H plus and OH minus? C alpha water, C alpha is converted into H plus and OH minus. Okay, and from the equation we know that 1 mole of water gives you 1 H plus and 1 OH minus. So C alpha on dissociation gives how much H plus C alpha, how much OH minus C alpha. Okay, so when temperature is not mentioned, automatically we have we know that what to do. We have to take it at what temperature? We have to take it at 25 degrees centigrade. Now see, at equilibrium, H plus ion concentration is equal to C alpha, and alpha is equal to H plus ion concentration by C. And we know that H plus ion concentration is equal to how much? At 25 degrees centigrade, it is 10 power minus 7. 10 power minus 7 moles per liter. Then what is the concentration of water? 55.56 molar. Moles gets cancelled. Then alpha is equal to, I can write 100 into 10 power minus 9 by 55.56. Then what do you get? 1.8 into 10 power minus 9. So this is what degree of dissociation of water at equilibrium. What is that? Degree of dissociation of water at equilibrium. So we will be asked what? We will be asked equilibrium constant. We will be asked alpha, degree of dissociation of water. Not only that, we are also asked about self-ionization, self-protonation or autoprotonation constant. Autoprotonation constant. Self-protonation constant or autoprotonation constant, which is given by K. And we have studied that earlier, two water molecules gives rise to H3O plus OH minus. For this I can write K. K is called as, now only we have studied, it is autoprotonation constant. K is equal to H3O plus equilibrium constant. It's nothing but equilibrium constant for this reaction by H2O power 2. And we know that H plus ion concentration into OH minus ion concentration is 10 power minus 14 mole square per liter square by H2O 55.56 okay, molar square. So then on calculation, what do you get? So K is equal to, I can write it as 100 into 100 into 10 power minus 18, because I am using 100 into 100, so 10 power 4 I have multiplied with 10 power minus 18, so that I get 10 power minus 14 by 55.56 into 55.56 what is that? Molar square. Okay, so then I write 1.8 into 10 power minus 18 okay, So 1.8 into 1.8, 3 point approximately 24 something into 10 power minus 8. So what is this called as autoprotonation constant or self-protonation constant? What is that called as a self-protonation constant or autoprotonation constant? So self-protonation constant, this is one thing which is generally asked in the examinations. Alpha we need to remember. Next, what is that? Equilibrium constant we have to remember. Okay. Now let's come here. So this is in the form of printed. Some information is given. Already we have derived it. What is this? Equilibrium constant K equilibrium of water is equal to 1.8 into 10 power minus 16. And Kw at 25 degrees centigrade. At 25 degrees centigrade, it is equal to 10 power minus 14 mole square per liter square. And the value of Kw depends only on temperature. It does not depend on any other factor. As temperature increases, ionization of water increases and hence Kw increases. Okay. At 298 Kelvin in pure water or in neutral aqueous solutions, then H plus ion concentration is equal to OH, which is equal to 10 power minus 7. Okay. So that is about that is about the water, ionic product of water. Ionic product of water. So let us see. This ionic product of water, if you see, we have studied that ionic product of water is equal to H plus ion concentration into OH minus ion concentration. Okay. Then we have studied that at 25 degrees centigrade or 298 Kelvin, H plus ion Kw is equal to 10 power minus 14 mole square per liter square, right? Where H plus ion concentration is equal to 10 power minus 7 moles per liter and OH minus ion concentration is equal to 10 power minus 7 moles per liter. So here it is pure water and at 298 Kelvin. These are the conditions for neutral conditions. What is that? Pure water. So the conditions for neutral solution or neutral water, here neutral. Neutral represents that it is neither acidic nor basic. For a neutral solution, H plus ion concentration is equal to 10 power minus 7 moles per liter and OH minus ion concentration is also equal to 10 power minus 7 moles per liter. Okay. So neutral, if you take neutral, here H plus ion concentration, let me consider H plus ion concentration. Okay. H plus ion concentration. So H plus ion concentration. H plus ion concentration is equal to 10 power minus 7 moles per liter. Or OH minus ion concentration is equal to, it is also equal to 10 power minus 7 moles per liter. So these are the conditions for what? Neutral. If H plus ion concentration is greater than 10 power minus 7, that means 10 power minus 6 moles per liter, then what is this? If H plus ion concentration is 10 power minus 6, then what will be OH minus ion concentration? We know that H plus ion concentration into OH minus ion concentration is equal to 10 power minus 14 mole square per liter square. You are given H plus ion concentration 10 power minus 6. Then OH minus ion concentration will be equal to 10 power minus 14 mole square per liter square by H plus. H plus is so much given 10 power minus 6. Then what you get 10 power minus 14 plus 6. That is equal to 10 power minus 8. Okay. So this is 10 power minus 6 moles per liter. So moles per liter gets cancelled. You will get moles per liter. Are you getting this? So overall on multiplying these two, you should get 10 power minus 14. Then what will be OH minus ion concentration here? OH minus ion concentration will be 10 power minus 8 moles per liter. That means in a solution, if H plus ion concentration increases, OH minus ion concentration decreases. OH minus ion concentration decreases. And if H plus ion concentration is greater than, if H plus ion concentration is greater than 10 power minus 7, then that will be acidic solution. And if OH minus ion concentration is less than 10 power minus 7, that is again acidic solution. So acidic solution can be defined in two ways. One way is that it should contain H plus ion concentration greater than 10 power minus 7, or it should have OH minus ion concentration less than 10 power minus 7. Okay. So if you go on increasing H plus ion concentration, see, let me increase it to 10 power minus 5 moles per liter, or 10 power minus 4 capital M, 10 power minus 3 capital M, 10 power minus 2 capital M, 10 power minus 1 capital M. So these are all below 10 power minus 6, 10 power minus 6, 10 power minus 5, 10 power minus 4, 10 power minus 3, 10 power minus 2, 10 power minus 1. All these are greater than 10 power minus 7. All these are greater than 10 power minus 7. That means all these solutions are acidic in nature. When you go on increasing H plus ion concentration, the acidic strength goes on increasing. I can say that it is more acidic. I say that it is less acidic. 10 power minus 6. H plus ion concentration 10 power minus 6 is less acidic. Whereas coming to, if it is 10 power minus 1, it is very much a high H plus ion concentration when compared with 10 power minus 7. So it will be more acidic because H plus ion concentration is more. More H plus ion concentration, more acidic. Okay. So for 10 power minus 6, OH minus ion concentration is 10 power minus 8. For 10 power minus 5, OH minus ion concentration will be 10 power minus 9. 10 power minus 9 into 10 power minus 5 gives you 10 power minus 14. Are you getting this? This is what neutral. This is neutral. And when you are comparing with this, others are compared with this. Okay. Now 10 power minus 4. Then what will be OH minus 10 power minus 10 molar. 10 power minus 3 means 10 power minus 11 molar OH minus ion concentration. Here 10 power minus 2 H plus ion concentration means here this will be 10 power minus 12. So 10 power minus 12 into 10 power minus 2 gives you 10 power minus 14. In the same way, if H plus ion concentration is 10 power minus 1, then this will be 10 power minus 13 molar. If it is 10 power 0 molar, then it will be 10 power minus 14 molar. Okay. So more the H plus ion concentration, more acidic, very less OH minus ion concentration, more H plus ion concentration, more acidic, less OH minus ion concentration, more acidic. If you go with the similar OH minus ion, see, I am mentioning it as 10 power minus 6 molar. See, OH minus ion concentration here is more than 10 power minus 7. If more OH is present, then we say that it is more than 10 power minus 7 OH minus ion concentration leads to basic nature. What is this, sir? This is all basic. Basic. Below what we have seen, this is all what? Acidic. Acidic. When you go on increasing H plus ion concentration, acidic strength goes on increasing. Okay. In the same way, now what we are doing, OH minus ion concentration we are increasing. So 10 power minus 6 is greater than 10 power minus 7. In the same way, 10 power minus 5 is greater than 10 power minus 6. In the same way, 10 power minus 4 is greater than 10 power minus 5. 10 power minus 3 is greater than 10 power minus 4. 10 power minus 2 is greater than 10 power minus 3. 10 power minus 1 is greater than 10 power minus 2. Okay, in that way. H plus ion concentration, let us take, if it is 10 power minus 6, it will be 10 power minus 8 molar. Like that, 10 power minus 9 molar, 10 power minus 10 molar. See, you have to multiply these two. Okay, these are all what? H plus ion concentrations. So, like 10 power minus 11 molar, 10 power minus 12, 10 power minus 13. So, if it is 10 power, what we can write? 0 molar, it will be 10 power minus 14. Okay, 10 power minus 14. Did you get this? So now H plus ion concentration, you see, 10 power minus 6 is greater, 10 power minus 6 is greater, or 10 power 0 is greater, 10 power 0 is greater. As 10 power 0 is greater, OH minus ion concentration, we are speaking about OH minus concentration. More OH minus ion concentration, more basic. Now I can write it is more basic. Here it will be less basic. So simple understanding is that if H plus ion concentration increases, okay, simple what you can write, more H plus ion concentration or less OH minus ion concentration, it will be acidic solution. More OH minus ion concentration or less H plus ion concentration, it will be basic. It will be what? Basic. Are you getting this? So these points, if you can remember, then that is sufficient to understand which is acidic and which is basic. And if H plus is equal to 7 and if OH minus is equal to minus 7, H plus 10 power minus 7 and OH minus 10 power minus 7, that will be neutral. That will be neutral. At what temperature? 25 degrees centigrade. If you change the temperature, H plus changes as well as OH minus also changes. Already we have studied that on increasing temperature, H plus decreases, the same OH minus also decreases. Understood? Understood? Right? So that is about here acidic and basic strength. Looking at H plus ion concentration at 25 degrees centigrade, we can decide whether the given solution is acidic or basic. Okay. Now let us see, let us solve some questions on this. Let us solve some questions. First question, which of the following is not true for acidic solutions at room temperature? Not acidic. Not acidic. So at 25 degrees centigrade, we have studied that at now only we have studied 25 degrees centigrade, H plus ion concentration 10 power minus 7 moles per liter, and OH minus ion concentration 10 power minus 7 moles per liter. If it is acidic, for example, let us take one. H plus ion concentration is equal to 10 power minus 6 molar, and then OH minus will be 10 power minus 8 molar. Can I say that from this side? Can I say that H plus ion concentration is greater than OH minus ion concentration? Yes, because H plus is 10 power minus 6, OH minus is 10 power minus 8. 10 power minus 6 is greater than 10 power minus 8. So it is correct. H plus ion concentration is greater than 10 power minus 7. See, 10 power minus 6 is greater than 10 power minus 7. 10 power minus 6 is greater than 10 power minus 7. So this is also correct. H plus ion concentration is less than 10 power minus 7. If H plus ion concentration is equal to 10 power minus 8 m, then that will be what solution? Basic solution. If H plus ion concentration is less than 10 power minus 7, then this is acidic. What is this? This is also acidic. But what is this? This is basic. So OH minus ion concentration for 10 power minus 8, OH minus ion concentration total should be equal to 10 power minus 14. So 10 power minus 8 into what gives you 10 power minus 14? 10 power minus 6 molar gives you 10 power minus 14. So for acidic solution, he is asking for acidic solution. So for acidic solution, H plus ion concentration is greater than 10 power greater than OH minus ion concentration. Now what about OH minus ion concentration? See here, OH minus ion concentration is 10 power minus 8. So OH minus ion concentration is less than 10 power minus 7. Is 10 power minus 8 greater than 10 power minus, or is 10 power minus 8 greater than 10 power minus 7 or less than 10 power minus 7? 10 power minus 8 is less than 10 power minus 7, right? So I can this is also acidic condition. So not true for acidic condition. This will be not true for acidic condition. Why? Because H plus ion concentration must be greater than 10 power minus 7 at room temperature. Room temperature is 25 degrees centigrade or 298 Kelvin. Understood? Right? Now, let us go with the second question. If HCl is added to pure water at 25 degrees centigrade, the ionic product of water will be, already we have studied that there is a solution, there is water. What is that? Pure water. Into this pure water, what you are doing? You are adding acid. When you add acid at a particular temperature, 25 degrees centigrade, it becomes acidic solution. It becomes a acidic solution. That means H plus ion concentration increases. What happens? H plus ion concentration increases. Because you are adding acid. Acid contains H plus. So H plus ion concentration increases. When H plus ion concentration increases at a particular temperature, automatically OH minus ion concentration decreases. Before we have seen, see here, if H plus becomes 10 power minus 7, OH becomes, if H plus becomes 10 power minus 6, OH becomes 10 power minus 8. If H plus ion concentration increases, OH minus ion concentration decreases. But overall ionic product of water is equal to, it remains constant, 10 power minus 14 moles per liter square. ionic product of water depends upon only temperature. If you add acid or if you add base to it, ionic product of water does not change. So here on adding water at a particular temperature at 25 degrees centigrade, if you add acid or if you add base, whatever it is, ionic product of water does not change. It remains 10 power minus 14. Okay, so that is what. The third question, let us. The ionic product of water changes when an acid is added to it, a base is added to it, either a acid or base is added to, temperature is changed. Now only we have discussed that it does not depend on any other factor, it depends upon only temperature. So the answer is temperature. Understood? Next question. At 25 degrees centigrade, H plus of solution is 2 into 10 power minus 9 molar. The nature of the solution is, so we know that H plus ion concentration is equal to 10 power minus 7 molar at 25 degrees centigrade, then that is neutral. You are given H plus ion concentration 2 into 10 power minus 9 molar. What is this? It is greater than 10 power minus 7 or less than 10 power minus 7? It is less than 10 power minus 7. Less than 10 power minus 7. If H plus is less than 10 power minus 7, then what we have studied, it will be basic. If H plus ion concentration is greater than 10 power minus 7, that will be acidic. As here H plus ion concentration is less than 10 power minus 7, so the answer will be basic. So we are discussing very basic level questions actually. Okay. For the purpose of understanding the concept. For the purpose of understanding the concept, we are learning very basic level of questions. So what will be the answer here? The solution will be basic here because H plus ion concentration is 2 into 10 power minus 11, which is less than 10 power minus 7. 2 into 10 power minus 9 is less than 10 power minus 7. Understood? Okay. Now, at any temperature, the proton concentration of water is. So, we know that Kw is equal to H plus ion concentration into OH minus ion concentration. And we know that H plus ion concentration is equal to OH minus ion concentration at a particular temperature. At a particular temperature. Okay. So now I can write that Kw is equal to H plus ion concentration into H plus ion concentration, because OH minus ion concentration is also called as H plus ion concentration. It is equal to H plus ion concentration. Now I can write it as H plus ion concentration square is equal to Kw. Then H plus ion concentration is equal to root Kw. So you are finding root Kw. At any particular temperature, whatever the temperature it is, H plus ion concentration will be equal to OH minus ion concentration. For proton concentration of water, he is asking only water, he is not asking any solution, acidic solution or basic solution. He is asking only water, in the water. Okay, for example, at we know that at 25 degrees centigrade, Kw is equal to 10 power minus 14. Okay, so H plus ion concentration is equal to root Kw, which is equal to 10 power minus 7. This is molar square, this is molar. In the same way, I can also write OH minus ion concentration is also equal to root Kw, that is equal to 10 power minus 7 molar. For example, let me take at 50 degrees centigrade. 50 degrees centigrade. Let me take it as 10 power minus 12 molar square. Why? Because on increasing temperature, ionic product of water increases. Now I am writing H plus ion concentration is equal to root Kw, that is equal to 10 power minus 6 molar, or OH minus ion concentration is equal to root Kw, that is equal to 10 power minus 6 molar. So whether it is H plus ion concentration or OH minus ion concentration for water at a particular temperature, it is equal to root Kw, is equal to root Kw, right? So let us go with the next question. The ionic product of water is 10 power minus 14, that is at 25 degrees centigrade. The H plus ion concentration in 0.01 m NaOH here given. So NaOH is strong electrolyte. When it is strong electrolyte, it completely dissociates. It completely dissociates into Na plus and OH minus. If one molecule of NaOH is dissociating, one molecule of Na plus and one molecule of OH minus is formed. If 0.01 m, what is that? 0.01 m is dissociating, how much OH is produced? 0.01 m. And you know OH minus, we want H plus ion concentration. And you know that, okay, H plus ion concentration into OH minus ion concentration is equal to Kw, which is given as 10 power minus 14. And you are asked H plus ion concentration, that is equal to 10 power minus 14 by how much OH minus concentration? 0.01, that is equal to 10 power minus 14 by 10 power minus 2, that is equal to 10 power minus 12. Yeah. Okay. So the answer is 10 power minus 12 molar. Understood? Simple logic. Coming to the next question, 0.4 grams of NaOH is present in 1 liter of the solution, and it shows that H plus ion concentration of the solution is asked. H plus ion concentration is asked, right? So now molarity can be calculated. Let us calculate concentration of NaOH. What is that? Concentration of NaOH. That is molarity. Molarity is equal to number of moles by volume in liters. So number of moles means weight by molecular weight by volume expressed in liters. Weight is given 0.4 grams by gram molecular weight is 40 grams by volume is 1 liter. That is equal to 1 by 100. So NaOH concentration is 1 by 100 molar. That means 10 power minus 2 molar. How much is that? 10 power minus 2 molar. 10 power minus 2 molar. So 10 power minus 2 molar, NaOH dissociates into Na plus plus OH minus. As NaOH is strong electrolyte, it completely dissociates. Then how much is produced? 10 power minus 2 molar is produced. And we know that at a particular temperature, H plus ion concentration into OH minus ion concentration is equal to 10 power minus 14. And what is asked? H plus ion concentration. H plus ion concentration is equal to 10 power minus 14 by OH. We have studied, we have found out that it is 10 power minus 2. Then that is equal to 10 power minus 14 plus 2. That is equal to 10 power minus 2 minus 12. So answer is 10 power minus 12. Understood? Now let us see. At some high temperature, the value of Kw is 10 power minus 12. Calculate the H plus ion concentration of water at the same temperature. So we know that Kw is equal to H plus ion concentration into OH minus ion concentration, and we know that at a particular temperature, H plus ion concentration is equal to OH minus ion concentration. Then I can write Kw is equal to H plus ion concentration into H plus ion. OH also I can take it as H plus. So then I can write Kw is equal to H plus ion concentration square. H plus ion concentration is equal to root Kw, that is equal to root, how much is given? 10 power minus 12, 10 power minus 12, that is equal to 10 power minus 6 molar. Okay, so 10 power minus 6 molar. Understood? Next, coming to at a certain temperature, the H plus ion concentration of water is 4 into 10, then the value of Kw is, okay. Now only we have seen at a particular temperature for water, we know that Kw is equal to H plus ion concentration square. So you are asked Kw is equal to H plus ion concentration 4 into 10 power minus 7 molar square. Then what do you get? 4 16. 16 into 10 power minus 7 into 2, 10 power minus 14 molar square. Then that is equal to, I can write 1.6 into 10 power minus 13 molar square. So where is the answer? Here is the answer. Okay. Next, what is the question? Calculate the H plus ion concentration of 0.008 mCaOH taken place. So calcium oxide, considering calcium oxide, here it is a strong electrolyte. That means CaOH taken twice gives rise to Ca plus 2 OH minus. Here its concentration is 8 into 10 power minus 3 molar. So 1 mole of calcium hydroxide on dissociation gives 2 moles of OH. So how much amount of OH is produced? 2 into 8 into 10 power minus 3. This much is produced, OH minus N. Okay, molar. Now we have OH minus, we want H plus. So we know that H plus ion concentration at a particular temperature is equal to 10 power minus 14 by OH minus ion concentration, which is equal to H plus ion concentration is equal to 10 power minus 14 is 10 power minus 14 by 2 8 16, 16 into 10 power minus 3. Okay, then what do you get? 10 power minus 11 by 16. I can write 100 into 10 power minus 13 by 16. 16 6 96. So what do you get? 6.25 into 10 power minus 30. So where is this? This is here. Molar. Understood how to solve? Okay. So next, coming to the next question, let us see the next question. Here, the number of H3O plus ions present in 10 ml of water at 25 degrees centigrade. At 25 degrees centigrade. Okay. So first of all, we know that molarity, and we know that at 25 degrees centigrade, what is that? At 25 degrees centigrade, H plus ion concentration is equal to 10 power minus 7 moles per liter. Okay. Moles in 1 liter. But here it is asked 10 ml. 10 ml. So in another way, it is also called as molar. And we know molarity is equal to number of moles by volume in liters. So number of moles is equal to molarity into volume in liters. Molarity how much given? 10 power minus 7 we know into, okay, Volume 10 ml given. So 10 by 1000. Why we have divided with 1000? Because it is it should be expressed in liters. Then this is equal to 10 power minus 9 moles. Number of moles. Okay. H plus is nothing but we know that one H plus combines with one H2O gives rise to one H3O plus. So H plus ion concentration is nothing but H3O plus concept. What we can write? H plus can also be represented as what? H3O plus ion concentration. So number of moles. So number of moles is equal to 10 power minus 9 moles. 1 mole is equal to 10 power minus 9 and 1 mole is equal to 6.023 into 10 power 23, which can be written as 6.023 into 10 power 23 minus 9. 23 minus 9, how much? 12. 12 plus 9, 23, right? So 12. 23, 12, no, 14, no, right? 14 plus 9, 23. 14 molecules. So how many molecules of H3O plus are there? 6.023 into 10 power 14. So 6.023 into 10 power 14 molecules. Understood? Next, let us take find out OH minus ion concentration in 100 ml of 0.05 m HCl. Okay, HCl is strong electrolyte. HCl dissociates to form H plus and Cl minus. One molecule dissociates to form 1 and 1. Okay, here 0.05015 m gives rise to H plus 0.015 m. And when temperature is not mentioned, what we have asked to do, we have to take at 25 degrees centigrade. And H plus into OH minus concentration is equal to 10 power minus 14 molar square. Then what is asked? OH minus. OH minus is equal to 10 power minus 14 by H plus is how much? 15 into 10 power minus 3. I can write it as 10 power minus 11 by 15. 0.015 can be written as 15 into 10 power minus 3. Then that is equal to 100 into 10 power minus 13 by 15. 5690. So what do you get? 6 point approximately 7 into 10 power minus 13 molar. Okay, so I can take 6.7 into 10 power minus 13 molar. Understood? Next, coming to question number 13. The OH minus ion concentration of 0.005 m H2SO4 is. Again, H2SO4 is strong electrolyte. H2SO4 is a strong electrolyte. It dissociates to form 2H plus SO4 minus 2. 1 produces 2H plus. Okay. 1 H2SO4 produces 2 moles of H plus. 1 mole produces 2 moles. Here, what is the concentration of H2SO4? 5 into 10 power minus 3. We get 2 into 5 into 10 power minus 3 molar. Okay, that is equal to 10 into 10 power minus 3. That means 10 power minus 2 molar. Then temperature is not given. When temperature is not given, what you have to take 25 degrees centigrade. Then what you can write? OH minus ion concentration is equal to 10 power minus 14 by H plus ion. That is equal to 10 power minus 14 molar square by H plus is 10 power minus 2 molars. Okay, then that is equal to 10 power minus 2 or molar. That's the answer. Okay. Next, coming to the OH minus ion concentration of a solution is 3.2 into 10 power minus 4. Find the H plus ion concentration of the same solution. Okay, simple one. Solution it is given, not water. Not the water. And temperature is not given. When temperature is not given, we have to take it as at 25 degrees centigrade. Then H plus ion concentration is equal to 10 power minus 14 by OH minus ion. That is equal to 10 power minus 14 by 3.2 into 10 power minus 4. That is equal to, then what you get, 10 power minus 10 by 3.2. I can write it as, okay, 10 into 10 power minus 11 by 3.2. So approximately 3 point something you will get. How much? 3.125 into 10 power minus 11 molar. So what is the answer? This is right. Next, coming to 15th question. If the ionic product of water is, what is its value at 10 degrees centigrade? We know that when you decrease the temperature, ionic product of water decreases. Ionic product of water decreases. So at 25 degrees centigrade, we have studied that ionic product of water Kw is equal to 10 power minus 14 mole square per liter square, molar square. Then he is asking at 10 degrees centigrade. At 10 degrees centigrade, it will be Kw is less than 10 power minus 14 molar square per. It will be less than this. So now you say it is given as 35 degrees centigrade. 35 degrees centigrade, they have given us at ionic product of water is 1.96 into 10 power minus 14. 35 degrees centigrade. At 10 degrees centigrade, they are asking. At 10 degrees centigrade means you are decreasing the temperature. When you decrease the temperature, automatically ionic product of water decreases. So which value is less than this 1.96 into 10 power minus 14? You are here 2.95 into 10 power 14. So it is greater. 1.96 into 10 power minus 7. It is much greater. 2.95, 10 power minus 15. 10 power minus 15 is smaller than 10 power minus 14. So it is smaller. Then 10 power minus 12 is greater than 10 power minus 12. So it is greater. So what is asked? What is its value at 10 degrees centigrade? So this will be the answer. Understood? Hope so. Everyone understood this concept very well, because this is the basic concept for ionic equilibrium. If you don't understand, you revise the video, rewind the video, once again you listen. Every point I have discussed very clear. Every step I have written for solving the problems. In the concept also, every step I have mentioned. Every small detail is mentioned. Okay, so this is the basic one regarding ionic equilibrium. Once if you understand this, then only we can proceed to the next part of the chapter. So you thoroughly go through this video. With some patience, you go through this video so that you can understand the concept very well. Okay, thanks for watching. We shall meet in the next class with a new topic. Right.